Hey, Melissa.
Yeah, what's up?
The people have some corrections for us.
Oh, no.
Yep. Some
well, that's
things.
good. That's good. We like that.
Yeah, we like the corrections. There's some questions as well about cleaning with vinegar and baking soda. A question that
Yes.
I feel like we've gotten a lot, and that's will be good for you to answer. And then something about kombucha, which I'm always glad when that comes up. So we got some good questions from our community today.
All right. Let's get into it.
You ready for them?
Yes, I'm ready. Ask away.
All right.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life. Bonus edition.
He almost forgot it.
I was trying to gauge where you're going to say ask a chemist edition or bonus.
Yeah.
So,
or chemistry support.
Yeah. All of the above. Today, you all are asking a chemist something, and you're trying to get some chemistry support for your life.
Hey, that's me.
So should we just jump right in?
Yeah, let's do it.
This first one is a correction. These first two are corrections. This is from Jeanette. I read this one also, and I'm excited about it. When discussing kombucha sometime back, Jam, you suggested that additional sugar was needed on the second ferment for carbonization to occur. Carbonation, I guess?
Yeah, probably.
I humbly beg to disagree. Fruit, which of course contains fructose, is a sufficient source of fruit for, or maybe I guess sugar for this ferment, and one I've successfully used for years now. I've never added sugar except for when making the hot tea. Keep up the great work, you two. Can I respond
Jeanette
first?
is a community member also.
Yes. Oh, yes. Yes, she is.
Yeah, I think you should respond first.
Okay, so Jeanette, you're totally right. When I said sugar, I really did mean sort of any kind of sugar.
Yeah.
Like it needs something or it won't do a second ferment. But I completely agree with you. I should have been more careful of the way I said it. All of my second ferments didn't include adding additional like granulated sugar.
Yeah.
All of mine were something that has sugar in it, like fruit, which is pretty much all I did, I think.
Yeah.
Fruit and ginger. And it was always enough. You're totally right. So there's plenty there to like do another ferment. And I think one of our friends who also did kombucha, I think he actually did do some sugar in his second ferment. But yeah, I agree with you. I didn't find it necessary because if you're not letting all of the sugar from your first ferment, if you're not going to letting all of it get eaten up, then it doesn't get too sour and tart. And then you're adding fruit, which adds some sugar. Mm-hmm. So you shouldn't really need to. But our friend Ryan did add a lot.
He used to call it booch also.
Yeah. Well, the whole booch community has all kinds of slang. So
I don't love it.
He has a lot of company.
Yeah. I actually don't have any response to that.
Okay.
My only thought was, oh, well, that counts as sugar.
Yeah. But I didn't, just depending on who's listening, if you say you need sugar in the second ferment, it sounds like you need sugar.
I agree. Yeah.
So
yeah, I agree.
Jeanette's right to make me clarify that.
Yes, I agree. Good job, Jeanette. Keeping us on our toes.
And every time you or anyone else asks anything about kombucha, I get this much closer to getting back into it. So.
Oh, okay. Well,
into making it, I mean.
Something I've wondered about is we have ginger beer that's brewed locally in Denton, and it is really good. And I'm like, should we do that?
That I could get into.
Yeah, me too.
Maybe we should all combine forces and do that.
Maybe so.
Because I think it's very similar, but they call it a ginger bug. Is the the thing you cultivate or whatever.
I think it is probably sugarier too. Mm-hmm. But we could probably make it less sugary.
Yeah. Yeah, my biggest thing, I don't know how you feel about this. I would love to make it very gingery.
I do like ginger a lot. Yeah.
Like where it's like spicy. Like, yeah. Okay. All right.
I mean, we could have two levels too. We could have ginger bite and ginger.
Yeah. We could maybe call it like this one's like for little babies.
Yeah.
And this one's for like adult humans.
Yeah. Mm-hmm.
Who like want to live life.
Right.
And want their drinks to like tingle.
Sometimes I'm like a little baby and sometimes I'm like an adult human. So I like having both options.
Nice. We should do that at least once. We should look into that and try it.
That would be fun. We could document it and put it on Patreon.
I think there's a few things that are different in the process, not just what you start with, but I don't remember what they are. That'd be a fun patron specific sort of behind the scenes thing.
Yeah.
This may or may not go well. What if we make something disgusting, but we'll find out together.
Yeah, we will.
Okay. Correction number 2. I believe this one's more for you than me.
Okay. Yeah, fair enough.
Elise, which is how most of these go anyway. But Elise, this is from Elise through the website. Wait, did you write this little thing ahead?
Yeah.
Okay. Elise said that this is a correction from the drop down thing we have, but then she wrote, I feel like addition is more the appropriate term because you, Melissa, were eventually correct about isotopes. I'm a teaching professor. I have a PhD in inorganic chemistry, and I teach general chemistry too. I, too, used to have a hard time remembering whether it was a different amount of protons or neutrons that make isotopes.
That is so good to hear that I'm not the only one who is a chemist who teaches other people chemistry and forgets things like that. They just slip away.
Yeah, that is good. That is good to know. I'm sure it makes sense that everyone would forget stuff.
Yeah, it does, but it still feels bad when you're like, I'm supposed to be a chemist.
The way I remember and what I tell my students is that the atomic number on the periodic table is based on the number of protons. In nuclear chemistry, if the number of protons changes, the element changes. So the element is the same, but it must be a different number of neutrons that make isotopes. I recently started listening, love the show, and I got to the episode where you talked about the Dutch translation of hydrogen bonding to hydrogen bridge, which is from one of our patrons, right?
Doreen.
Yep. But right before I covered intellectual forces, amazing. Thank you. Cheers, Elise.
Yes, Doreen. That is a big hitter for me, and I really appreciate it.
Yeah, that was really cool. And that's wait, so I wonder if Elise is working backward then maybe?
Maybe.
That was not that long ago, right?
Yeah, I bet so. And, I get that because it's higher quality. And I will say, Elise, thank you for sending this. It was very comforting to read, and it was good to remember because it was I was like, what's happening? And so I do think in nuclear chemistry, neutrons determine what the atom is will help me.
Wait.
Right?
Oh, the number of protons changes. The element changes.
Dang it. See, I just did it.
So if the element's the same, it must be different numbers of neutrons that make the isotopes.
There you go. So I switched it. See, this.
Yeah.
Even in my correction.
Uranium, whatever, with they say the number at the end, like in Chernobyl, is different number of neutrons than normal uranium, right?
Yes.
That's what this is all about. The isotopes.
And that should help me because hydrogen has 1 proton.
I wonder if there's a way we could come up with a pun that would help.
I know. I need one. Okay, listeners, write in.
Yeah. Pun or mnemonic device of some kind or
proton
acronym.
Changes the isotopes.
Neutron.
Dang it.
The only reason I can remember this because I just read this. Proton changes the element.
Yeah.
Neutron changes the isotope.
Oh, yeah. You're right.
Yeah, someone can come up with something. I feel like there's a pun waiting there about how icy are these topes? But getting from there to neutrons, I don't know.
Yeah. Oh, yeah. I definitely need it. As you can tell, I can't even remember in one conversation. But it does make sense because hydrogen, when it loses electrons, is just 1 proton. And so if neutrons were the thing that decided, I don't know. I'm too tired.
Yeah, it doesn't have anything. It couldn't have anything to do with the hour, right?
Yeah, it is 11:23 p.m. and I woke up at probably 6 a.m.
This one's a question.
Okay.
Actually, I guess there are 2 questions. Are these meant to be together?
Yeah, they came in and I felt like they were the same.
Nice. Okay, cool. So these 2 questions that go together are from Craft Scion on YouTube is the first one. I have a question. A ton of people on YouTube recommend combining baking soda and vinegar to clean with. I always thought when a base and acid are combined, you get water. Am I missing something? I almost responded to that person, by the way, because I was like, we talked about this. But I'll say nothing else. Then KB on Instagram said, thoughts on cleaning products / chemicals used.
Here's my hot take. Baking soda and vinegar is a scam.
What about baking soda or vinegar?
Not a scam. Okay, and I was in a room of chemists when this came in.
Oh, nice.
And we were actually waiting for another chemist to finish their defense. And we had nothing to talk about.
Mm-hmm.
And I said, here's my quick question for you all. Why do you think people use baking soda and vinegar? And so we were talking about it, and most people were like, yeah, they just neutralize each other. Like everybody kind of said that. But then one person was like, well, there's like these things and they'll do it and it seems like it cleans better. And my theory is just, and we have talked about this before, that it makes a paste that mechanically cleans. Like it is an abrasive paste. And or there's excess of one or the other.
Right.
And that one is actually good at cleaning.
Totally. And like imagine when you're doing this, you're putting probably the vinegar first, would be my thought if it was me. So then some vinegar is hanging out in whatever thing you're cleaning for a second on its own. And maybe it gets a chance to do its thing before you neutralize it.
Yeah.
So you're thinking, wow, the vinegar and baking soda did something special. It's like, actually, it was just one or the other that did it.
And it could be the bubbles dislodge things, like having a like violent outburst of, whatever of air, and it's relatively violent to the small area it's in. That could push some stuff out that's like in a hard to reach place. In the same way that like hydrogen peroxide can if I have mold or something growing, there's a drain that needs to be tighter in the house that we're renting. And so sometimes stuff will get caught on there and it'll get moldy and it's disgusting. And to clean it, hydrogen peroxide like pushes, I've watched it, I'll like scrape it out and then put hydrogen peroxide and it'll push stuff out with the foaming action.
Yeah.
So I think it's the abrasion and the foaming action. But also I think it just feels good to people. They're like, look at all that bubbles happening.
Yeah. Which I guess like what's tough about that is that like soap has bubbles.
Yeah.
And is cleaning things. So maybe we just kind of get stuck on like, well, there's bubbles.
Yeah.
That's good.
Yeah.
Yeah,
but soap doesn't like bubble up in the same way, which probably doesn't force things out as easier.
Right.
But you should definitely be using soap to kill germs and not just cleaning with baking soda and vinegar. You could just clean with vinegar and you probably don't need the baking soda, or vinegar and salt, and it'll have a better abrasive property.
Part of our roaster that the manual has us put a specific part in some hot water with baking soda in it, but its directions are very specific. It's like put some of this many like tablespoons of baking soda, this much water, and you put that thing in there for a certain amount of time. It's like it's apparently not good for it longer.
Yeah, I bet it's reacting with the metal or whatever. It's like reacting with whatever's on the surface, and if you do it for too long, it's going to start breaking down the metal.
But it works
or something.
like amazingly well, and soap doesn't. It's like this stuff gets so it's not germs, obviously. It's like a residue that is being sort of baked on at these high temperatures. So anyway, it's like things like that where I'm like,
sodas.
Oh, that's why it works.
Yeah.
Okay, now we know.
No, I can't make jokes like that when I'm supposed to be the expert. Yeah, I do think that baking soda is a base, and so it can chemically react with things and make them more accessible to water and or soap or whatever. And same thing with acid. Vinegar is an acid, and so them by themselves not a scam, but them together it just neutralizes each other, and you just have an excess of one or the other, which would have been the same as only using that one thing. But the bubbles probably do push some stuff out, and I do think the paste of the baking soda could be abrasive.
It's also interesting how like that thing specifically says to do that, and probably like those are probably the areas where it's like, oh, do this because it says to do this. They've planned that ahead. But sometimes I think we're all just guessing. It's like, well, do I need to actually use baking soda on X, Y, or Z? Like, why am I doing that?
Yeah, if you can think about it being like my brother had a smoker that lived in a room in his house, and so he was like trying to treat the walls with all this stuff, and I was like, I'd probably do a basic spray and then an acidic spray, like if that didn't work, and then like I was like trying to think of all the things I would do to treat it. Yeah.
Interesting. Okay, ready for this one?
Yes.
It's from Crystal B on their website. What's the difference between using eggs, mayonnaise, and sour cream as an adhesive for panko, breadcrumbs, and cooking? Between those three things, I see. I've made several recipes with panko and have used all three of those at different times. Other times, recipes just have me add some olive oil to the panko mixture. Are there other adhesives for cooking, and do they all have different effects on flavor, texture, etc.?
So, do you know what I'm going to say? Do you have a guess? I can just go for it.
I don't think I do. I was thinking about how I watched this video about how they make panko breadcrumbs, and it's like kind of insane.
Oh, I don't know about that. But I will say all these things have fat in them. And so my guess is that fat has the action that you want of some kind. Maybe it's sticky when you put it together. I don't know. But I would say the thing that would have a difference on the texture and the flavor would be the other molecules that are present. Like olive oil obviously tastes different than like sour cream. And then the texture is probably the fat content. And then the content of other things that are present. We actually use Greek yogurt. We have like a recipe where we just smush down some panko breadcrumbs on top of some Greek yogurt and it's nice and creamy. And some homemade pesto with it too. So it's like high protein, but also like nice flavor. And pair it with some veggies because we all need more fiber.
Yeah.
And it's really good and easy to bake in the oven.
Nice.
So I think it's just fat. I think you just need fat. That's my guess.
And I
bet they would all be interchangeable.
And then there's obviously some benefits to some versus others that wouldn't be about texture, but might be like, oh, I'm trying to use more of this or less of this. Like Greek yogurt recipes, have their advantages depending on what you're trying to do.
Yeah. But then something else might be better if you're going for something else.
Yeah.
For me, it's hard to have too much dairy that's not like fermented in some way, basically. So yeah, that's why part of why I go with that.
The way this would be cool for you to look into, but the way they make panko breadcrumbs is that they run like an electrical current through the stuff. It makes this like these huge thin sheets of the stuff that like gets this.
Crazy.
The way that they are is not possible to be achieved by just like
blending them up.
Right. It's like you can't just like make bread and then blend it. It's like their way is very specific.
That's crazy.
I know. I kind of wonder, like, why do people go crazy for panko breadcrumbs? Like, it's one of the things where I hear about it. I'm like, I'm already annoyed because you guys are being so specific. Just get some breadcrumbs. And then at some point I heard that it's like, oh no, it's structurally different.
And that's why they're like crunchier.
They're built different, dude. Those breadcrumbs, they're just like crummier.
I don't think I know the difference, honestly, between panko and other ones. Like, I don't know if I would know the difference on. Well, maybe because you like bread. I don't know.
Yeah, I could probably tell in terms of just look, but I do have a mother-in-law who is very, very loyal to panko, so that's kind of why. Next question from Caitlin on Instagram. Hey guys, love the show. Just watched the rebroadcast episode about the ozone layer, and you mentioned that with the Montreal project, the ozone is expected to return to its original state by 2070. With COVID occurring and the restoration of the ozone layer during that time due to the lack of carbon production, do you think the ozone layer might heal at a faster rate than originally predicted? Whoa.
That's a great question. I think it's possible, but you know what else I think is it's really uncertain times right now, and our president, DJT, is trying to really pull back on a lot of climate benefits, like nice things to the earth, in favor of like fossil fuels and stuff. So I'm concerned about all the things. But so I think it's possible that could have been a good jump start. But I also think it's possible that we're undermining some of our efforts to improve the situation.
So may cancel out or worse.
Maybe. Yeah. But it'll be interesting to see.
Mm-hmm.
Like, and I haven't checked in. I honestly have not checked in on the ozone layer in a while. So I do remember during COVID it being like, whoa, this hole is smaller than we thought it was. And it is. I do think in general we've been like pleasantly surprised by how quickly it's bouncing back.
I feel like I've heard a few things like that, but I've wondered how credible they are.
Yeah.
Yeah, it's like we were all trying to check in on each other during the pandemic, but
Yeah.
who was checking in on the ozone?
Yeah. Caitlin was.
Yeah, Caitlin.
Good job, Caitlin.
Yeah, you're a good one. Next question from Anjali on Instagram.
I bet it's Anjali.
Anjali, I see. Maybe so.
I've had interacted with people at work with that name.
Yeah. I was kind of in my head pronouncing it in the way I would an Indian name or Pakistani name.
Yeah.
Where you kind of like do a long A. But
Yeah.
you're what you said makes more sense. Sorry.
I think either is possible.
Sorry, Anjali or Anjali. Either way, the question is, hi there. Huge fan. Love all your podcasts. I am a chemistry student in uni. Your podcast
So probably not from America.
That's true. Yeah.
If we say uni.
That's right. That's right. And your podcast helped me to understand chemistry behind a lot of things, I guess. Today, I was working in Shell, and our fridge was faulty. A lot of Monster Energy drinks started to explode crazy after it froze. I was wondering why. Hope you could make a podcast about it. Thank you.
Okay, well, first of all, thanks for the nice things you said. Also, probably, my guess is Australian from uni, I think. But I think that what happened is that when water freezes, it forms crystals that have more space between them than water molecules do. And that's a weird thing about water. Other things don't do that. But I bet that the Monster Energy drink had a high enough concentration of water that when it froze, it expanded. And water at that level of pressure is stronger than the can. And it can push out and bust open. So
yeah, interesting.
I think we have an episode about that. Water expanding, like probably the snowflake episode, maybe.
Yeah, and this exact question about water expanding when freezing came up separately from the snowflake one as well.
Yeah.
I can't remember when. It may have been a Q&R, but it wasn't about Monster Energy exploding. So this is definitely a new version of that, which I love. It's a story to it, It's like it's got all the, it's got all the intrigue and the chaos that you want.
Yeah.
In a good chemistry lesson. Man, crazy. I was wondering if it was going to be that they froze or they got warm. Like once
me too.
Once it got, but yeah.
Because either could happen.
Mm-hmm. In Texas, we have and I guess probably Australia as well. Probably if you leave some canned drinks, carbonated canned drinks in your car, they will explode.
Because then the gas is expanding.
Yeah.
Different reasons.
Oh yeah. That's crazy. The same thing can happen in completely opposite conditions.
Mm-hmm.
Wow. Next question is from David on our website. I know Mel has mentioned her research when she was in grad school, but what's her research like now? Can we have access to her published articles?
Yes, you can. My most recent research was during my postdoc, and I researched how doctoral education trained experts in chemistry. So how did people go from, chemistry undergraduates to experts? But really, like right now, we're just kind of laying the groundwork. And I just published an article about identifying challenges in doctoral education, and it's in an open access website. I think +1 is what it's called, PLOS1. I think you probably find me on Google Scholar, and that would work too. But I have beef with that paper because I had color coordinated. We identified these 4 major themes, and I color coordinated the 4 major themes, and then throughout the paper, I highlighted key findings in that color that corresponded to that theme, and they at the nth hour took them all out.
Weird.
I know.
Huh.
So it's disappointing.
That is. Scholar. I hardly know her.
That was terrible. That was like Seinfeld.
Yeah, kind of. Yeah.
Although
I feel like he would have maybe made that joke in an episode, but not in his
right. No, that's right. I think that was an episode, and it would be the short guy who would make that joke.
Yeah. George.
Yeah, that's what it made me think of.
This next question is from Sienna on Instagram, or Sienna. Wow, there's a bunch of ways to say that. Clays. How do polymer clays harden in the oven, and how does air dry clay harden?
I think they're the same basic. I'm guessing this is chemistry off the cuff. So air dry clay, I think, has enough moisture in it that it literally just stays wet, and when you put it out in the air, that evaporates. And when it evaporates, the thing left behind is no longer malleable. That's my guess. For polymers, polymer clay could be one of two things. It could be a similar thing where it's like, oh, there's moisture in this polymer and we're evaporating it in the oven, but we have to do it at a higher temperature because of the matrix or something being too close together. Or there is a chemical reaction between the molecules that make up the polymer clay. And when you expose them to heat, that's the thing that initiates that reaction. And then they all connect to one another. But since they're already in this shape, it hardens them. I think it's one of those two. But I could do a whole episode on it probably. But basically, polymer is just, those individual units, and they all connect to one another. So I think that's how they're doing it.
Interesting.
That's my guess.
Polymer. This question is from Renee on Instagram. If you could go back and have another career you'd be successful in, what would it be?
I don't think that's just for me.
Right, but maybe you should go first so I can think about it.
I feel like I could see myself doing something with wildlife biology. So like ornithology is bird science, or plants, some kind of plant science. But it's hard to get a job in those fields. But the caveat was we know we'd be successful.
Yeah.
I also like law, and I also have liked the idea of being a flight attendant, but I feel like that one could get old. I feel like that could be too close to waitressing, which I did enjoy, but I think, there's times it can leave you really jaded interacting with the public that much. Mm-hmm. So I think, but then I'm like, that's still science. Does that not count? So maybe a law school or, I just realized what it is.
What is it?
It's a baker. I would be a baker.
Yeah, of course. That's what you'd be.
That's what I'd be. I'd be a baker.
Yeah, 100%. And like, you'd be successful. So that part's already taken care of in this hypothetical. So you would love it.
Yeah.
You'd love it.
Yeah, I should definitely post. I posted this. I get these questions off Instagram because I like to be on social media, and I need to post an addendum to that one because I realized I'm wrong. What about you? What'd you come up with?
A couple. One of the ones I've thought of a lot because there's a part of me, this stuff, the AV related stuff is what I studied and worked in for a while. So I can't say that. But in general, just technology stuff, which is too broad. I've always been tech savvy and know that if I had chosen to like go do like computer science or something, that I think I would love it.
Yeah.
I don't, not motivated enough to learn that now.
Yeah.
And don't have a place to apply it. And it, so I don't want to do that. But I have thought for a long time, like, oh, that would have been a very viable route for me.
Yeah.
It's more, it would have been harder than what my degree was, I'm pretty sure. But I think I would have been in the same way that I would put a lot of work into like a film or something.
Yeah.
The idea of like putting a lot of work into something and it takes a while before you get to see it.
Yeah.
So I think that would connect. I would be okay with, I'm looking at lines and lines of code, and it's a while before I get to see the thing working, whatever it was I was working on. So, and I've dabbled just a little bit in it where like having to fix things on a website or something like that, where I have to like copy and paste pieces of code and hope that it'll work. Like on our Good Coffee website, I had to like patch which font it was going to use. So it'd use the font we wanted that wasn't already installed. Stuff like that where I'm like, this is so fun when you get it right and you fix it. So,
yeah, I do really enjoy that about coding. I've had to do a little bit of coding for my research, and is like, it does feel good. Yeah. And it is very problem solving, which you're good at. And you have to kind of keep information organized in your brain, which when I get a system, I'm good at that. But I think you're pretty good at keeping information organized in your brain either way.
Yeah. And the other one would be, obviously coffee could have been like the main thing.
Yeah.
If I like knew I'd be successful.
Yeah.
I think I'd be like, all right.
You could own a coffee shop and I could own a bake shop.
Yep.
Perfect.
Done. We just really made that our hypothetical careers turn into this other universe
where we still are a duo.
Yeah, exactly. Although those are things that both, obviously Mason already is involved in the coffee side, but Em could get in on in a way that neither of them want to on the podcast side.
Yeah.
So,
yeah, I think Em would like decorate and restore furniture and sell it in our coffee shop.
Yeah, and she may have some ideas of some, like, she wouldn't want to, like, get way in the weeds on baking.
Yeah.
But I could see her having an idea of, like, what if you could do this?
She'd be like, ooh, I found this recipe.
Yes.
Do you want to make it?
Yeah. Or I had this, and what if it was like that, but it was more this?
Mm-hmm.
That, I feel like she could be a good, idea person for you. Okay, fun anecdotes. These are 2 anecdotes from folks in our chem community that are super fun. Do you want to read one of these?
Sure, yeah.
Why don't you read the first one?
Okay, this is from Ash from our community. She said, just listen to episode 198 today. Love all things glow in the dark. I know I'm late on this, but I wanted to let you know I have an awesome fluffy blanket, super good here on Australian winter, that has glow in the dark thread incorporated, so it looks like stars in my glow in the dark stars on my bed.
Nice.
Isn't that so cute?
Yes.
And I'm also like, how did they get the thread to be glow in the dark?
Wow, that's crazy.
But also when I was in high school, my one teacher had all of our birthdays on glow stars, and we got given them at the end of the year. Over 12 years later, I still have it.
Wow.
And a comment about physical chemistry. It was actually one of my favorite and easier subjects. I found it a lot easier than OChem. I know. What a shock. Love you guys and keep it up. I'm almost caught up. Aw. Okay, Ash, but are you going to be sad when you're caught up? Number one, you won't know. We can't warn you until you're caught up, I guess, because you're getting so close to us. But 2, that was so cute. Thank you for sharing that. And I loved hearing about it, and I loved hearing about your star. And I guess somebody has to like physical chemistry, and it's not going to be me. So
right,
good on you.
Yeah, that is so interesting and cool. And also, catching up on the podcast when we have this many is such a cool feat. I do feel like it can be sad, but the fact that we are not like, on a hiatus or anything like that, when that happens in the podcast and then there aren't more. But what I found when I get caught up on a podcast that it's still actively releasing stuff, I actually kind of like it because I feel a little bit like like I don't have to, like, I'm current.
Yeah.
And it'll be cool to hear these episodes that come out and know that this was like just recorded. Like,
and
they're referencing something, and I'm like, I'm with them in this time too.
Yeah.
What are you gonna say?
Oh, just you get them every week.
Yes.
It's like every week you get excited for it instead of being like, I'm excited all the time.
Yeah.
So it's like kind of more rare, like a rare gift.
Yeah, for sure. That's all we have.
That's all she wrote.
Mm-hmm.
Well, thanks, Jam, for reading these questions to me. And thanks to our listeners for writing them in. That was great.
And thank you for answering them, even though I know you really didn't want to. Like,
no,
you guys,
I did.
right before we recorded, she was like, questions.
That's not true. I love questions. Ask my students. Also, I was really pleasantly surprised by how many people wrote in on the website.
Yeah. Awesome.
There's a lot of website, and that made it really easy to put everything together and to find them all and to give you credit. So I really appreciate that.
Yeah. Yep. Very cool. And yeah, it's just fun hearing from several of y'all, like, multiple times,
Yeah.
And we love that.
Building relationships.
Our community and others. It's very, very, very fun. So keep them coming. If you have questions, ideas, thoughts, feedback, corrections, any of that stuff, send them to us on our website. Like Melissa said, camforyourlife.com. camforyourlife.com. Share your thoughts, ideas, questions with us. If you'd like to help us keep our show going and contribute to cover the cost of making it, like some of our wonderful community members you've heard from today, you can do that. Join that group, the illustrious exclusive group at patreon.com/chemforyourlife, patreon.com/chemforyourlife. Perks, you get ways of us saying thank you. You get an ad-free feed of the show, monthly extra bonus episode, other things depending on which tier you pick. Just ways of us saying thank you for keeping the show going for everybody else's sake, and for us, of course, and keeping it free for everybody. We want the show to be free. And so thank y'all for doing that. If you're not able to do that, though, you can still help us by subscribing to your favorite podcast app, rating and writing a review on Apple Podcasts or Spotify, subscribing on YouTube, leaving a comment over there, buying a bit of merch from our merch store at chemforyourlife.com/store. Those things all help keep the show going, keep it free, keep it happening, and help other people to discover the show and learn about the chemistry of their everyday life.
That's right. We like to thank all those people who make that happen week in and week out by shouting them out by name. So we'd like to thank Chris, Claire, Hunter, Katrina, Lynn, Scott, Stephen, Timothy, Vince, Ash, Brian, Chelsea, Doreen, Elizabeth, Emily, Heather, John, Jesse, Latila, Rachel, Autoclave, Avishai, Chelsea, Sierra, Cullen, Emerson, Erica, Jacob, Jeanette, Julie, Justine, Christina, Suzanne, and Venus. Thank you all so much for everything you do to make this show happen. And thank you. And this episode of Chemistry for Your Life was created by me, Melissa Collini, and him, Jam Robinson. And we probably don't have any references today because this was all chemistry off the cuff.
Off the cuff.
Yay, chemistry!
Yay, chemistry!